Hello.
How are
Hi.
you doing tonight?
Good. How are you?
Good. All right. Coming down the home stretch here. When's your final? Is it tomorrow?
Yeah, it is.
Okay. What do you want to cover?
So I heard there was no decoding matrices, so we're good on that.
Okay.
But I just have a lot of problems with matrices, and then there's probability. No, that section where you have 4 or 5 formulas, and one is to find the nth term of an arithmetic sequence. That section.
Okay.
So I'll start off with some
Arithmetic sequences. A sub n equals a sub 1, the first term, plus n minus 1 times the common difference.
Okay,
That's an arithmetic sequence.
Mm-hmm.
You talking geometric sequences also? Because usually you study both at the same time. So this is arithmetic. Geometric is a sub n equals a sub 1 times the common ratio. I think it's that, isn't it?
I think so. Let's see if I have any of those in this review packet.
In other words, an example of a geometric series would be 2, 4, 8, 16. An example of an arithmetic series would be 1, 4, 7, 10. In other words, this first series, every term is separated by 3. This series here, every term is double the previous term. So the common ratio would be 2. So if I wanted to know what the third term was, a sub 3, it would equal 2 times the common ratio squared. That would equal 8. And that is what it's equal to.
Alright. So for this one, it's in the same section, but it doesn't use those formulas. It's write the first 5 terms of the sequence defined recursively.
Okay, recursively means that you're going to define the term based on the previous term plus d. So there's the recursive definition of an arithmetic series. In other words, the third term is equal to the second term plus the common difference, 3.
Okay. And then the equation, I guess, is a1 equals n, or a1 equals -1, comma, a sub k plus 1 equals a sub k minus 7. It's a sub k plus 1 down there.
Whoa, I got lost somewhere. A sub 1 equals -1. And what else?
Then it's comma, a sub k plus 1 equals a sub k minus 7.
And this is an arithmetic series or geometric?
It doesn't say.
A sub 1 equals -1, and a sub k plus 1 equals a sub k minus 7.
Yeah, it says write the first 5 terms.
Write the first 5 terms. Well,
Let's say we
first
need that
term is
n.
minus 1.
Yeah.
The second term, there's no way to do it from the information they've given us.
Oh, it says use the pattern to write the nth term of the sequence as a function of n. Does that help?
No. In other words, a sub 1 equals minus 1. So a sub k plus 1, how can that equal a sub k minus 7? That means like a sub 8, if k was 7, well, let's say a sub 9, let's make k 9, or rather 8. So a sub 9 equals a sub 1. So as all that tells me is that the 9th term equals the first term.
I can ask my teacher about it tomorrow.
Yeah, I'm very confused by this, and I understand series really well. So I'm confused by why I'm confused. It feels like we're missing some information here that you have to have.
Okay.
I don't understand the problem. Yeah.
This one says find a formula for a sub n for the arithmetic sequence a sub 3 equals negative 9 and a sub 10 equals negative 65.
They did say the arithmetic sequence?
Yes.
Okay. So what is the common difference?
Wouldn't you just take 7 divided by, or no, whatever the difference between them is divided by 7, so
56.
Divided by 7.
So negative 8. The common difference is negative 8. In other words, a sub 4 is minus 17, a sub 5 is minus 25, and so forth. So if we know that, then we can say, do they want it recursively or explicitly?
Does not say.
Well, I could always say that a sub n equals a sub n minus 1 minus 8. So that's its recursive definition. But if we want this formula here, then we need to figure out what a sub 1 is. If the common difference is minus 8, then a sub 2 is minus 1, and a sub 1 must be 7. So a sub n would equal to a sub 1, 7, plus n minus 1 times the common difference, minus 8. So there's the explicit formula for that. And if they want this multiplied out, which they probably do, so it would be minus 8n plus 8. So it would be 15 minus 8n. Okay.
And I've had the most problems with matrices, so I can probably do a lot of those.
Okay.
Okay, we can do this one. Solve the system of linear equations using an inverse matrix. and it's 4x plus 4y equals 2 over 8x minus 20y equals 6, or negative 6.
Alright, it's been a while since I've done matrices, but I think the way we're going to do this is this way. Let me think for a moment. If I multiply these two matrices, hold on, I'm going to have to get my book. So this is using Kramer's rule.
Okay.
Are you familiar with that?
Nope.
Well, there's lots of different ways to do this. Hold on a second. Alright, well, the first thing we want to do is evaluate the determinant of the system. If we're going to use Kramer's rule here, then x is going to equal the matrix E, B, F, D, and y is going to equal the matrix A, E, C, F divided by the determinant of this matrix, and this is divided by the determinant of this matrix. And it's AX plus BY equals E, and CX plus DY equals F. Okay, do you know how to figure the determinant of this matrix?
Isn't it AD minus BC?
It's AD. One moment, please. Sorry. Hello? Yes. Yes. I'm in the middle of a session. Sorry. It'll probably be about 8:45. Okay. See you then. Bye bye. All right. So what is that for this matrix? The determinant's equal to what?
The determinant would be 80 minus 2 is negative 112.
Okay. So my x value is equal to the determinant of this matrix divided by the determinant of the other matrix, and my y value is equal to the determinant. Now, do you know what these letters mean? In other words, the x value is going to be the determinant of E, which is 2, goes there. B, which is 4, goes there. F, which is minus 6, and D, which is minus 20,
Okay.
all over minus 112. So what is that number? What is that value right there?
I have no idea.
Well, it's minus 40 minus a minus 24. So that looks like minus 64. So x equals minus 64 divided by minus 112.
It wouldn't be minus 16 because it's minus 40 minus a minus.
Yes, you're right.
Okay.
You're absolutely right. Thank you. It's been a long day.
Yeah.
Okay, so that's the x value. And the y value, the matrix that we're going to substitute for that, A is 4, E is 2, C is 8, and F is minus 6. So what is this determinant? Minus 24 minus 16. That looks like minus 40. All divided by minus 112. So, assuming I haven't made any mistakes, I get 40 over 112 for that, and I get 16 over 112 for that. Now let's see if we can simplify that and plug it in and make sure we have the right equation. 16 goes into 112 7 times, so that's 1/7. Y is equal to 20 over 56, which is 10 over 28, which is 5/14. So y equals 5/14. And now let's see if that works. What was our equation? 4x plus 4y equals 2. 4x plus 4y equals 2. Well, that's 4/7 plus 5, plus 20/14, which is 10/7 equals 2. True. So that's our solution.
Okay.
That's using Kramer's rule. Now, there's other ways to do matrix algebra. But that's basically Kramer's rule. And it can be applied to a 3×3 matrix also. And probably you have in your book the formula for that. There's also inverse matrices and solving a system of equations by using inverse matrices.
Okay.
You're the one that asked me about decoding a message, aren't you?
Yeah, but we're not going to have that on our test, so.
Good. Because I didn't resolve that. I've completely spaced that out. I apologize. All right. Did you understand what I did here in applying Kramer's rule?
Yeah.
Kramer's rule pretty much requires you to memorize this. That the x value is going to be the determinant of that matrix divided by the determinant of the coefficient matrix. In other words, the matrix that I wrote right here was the matrix of just the coefficients. I didn't do this part. If you're going to use Cramer's rule, you don't apply this part here. And here is my two equations. So that's where I get the A, B, E, C, D, and F from. And I don't know a simple way to memorize those. You just, I guess, got to memorize them. Oh, I did remember a simple way to memorize those. For the x variable, you start on the far right and then go and use the other two coefficients, and that's how we get E and B. And for the bottom, you do the same thing. You start on the far right, and then you go back again and go through it. And notice for the y variable, it's A and E, and C and F. In other words, it's the coefficients that aren't part of that variable, going from left to right, always. And that same system applies to a 3 by 3 matrix. You go from left to right, you ignore the coefficient on the variable you're trying to solve for. All right. What else?
So this one says, evaluate the determinant of the matrix below to determine which of the following makes the equation true. And it gives you like a B, C, D, E for the answers, and the equation, or the matrix is W, then negative 5x.
Is it a 2 by 2 or a 3 by 3?
It's a 2 by 2. Over negative 4y and z.
Okay, so the determinant is what?
WZ minus 20xy.
And what's the problem again? What do they want?
It says evaluate the determinant of the matrix below to determine which of the following makes the equation true. It gives you an A, B, C, D, E, and E.
Okay, what's A?
A is negative W 5x over negative 4yz. Or like in a matrix though.
Excuse me. Good, because I was about to be very confused.
Yeah.
What is that again?
Negative W then 5x over negative 4y and z.
So the determinant of this would be minus WZ plus 20xy.
Oh, so do you just...
So that's the negative of this. If I were to put a negative sign in front of that expression, it would come out to be this. So that is not the same thing. What's B?
B is negative z, then 5x, negative 4y, and w. So what you would do is you just find the determinants of all of them and see if they match.
And which one matches, yeah. Again, this one is minus WZ plus 20XY. So this one's the same as A. So you need to find one that ends up being exactly that, WZ minus 20XY.
Okay. And then if you had like, for B, if you had that, but you just had a negative on the outside of the matrix, would you just multiply the determinant by negative 1?
Yeah. In other words, if I had that,
Mm-hmm.
yeah, that's negative, whatever the determinant is, put a negative sign in front of it. So actually, this is the negative of that determinant. In other words, this one is the negative of that one. Do you know how to find the determinant of a 3 by 3, and do you need to know that?
I think you do. Yeah.
Yeah, let's use letters.
Is there a way to do it on a calculator? Because I think we might do it on a calculator.
What kind of calculator do you have?
TI-84.
To be honest with you, I don't know how to do much in the way of matrices on that. That's my old calculator. I got a newer one. But the best answer to your question is go to YouTube.
Okay.
And type in how to find the determinant of a 3 by 3 matrix on a TI-84. And you'll be watching a 2-minute video that shows you exactly how to do it.
Right.
But finding it by hand is you put 2 dummy columns in that duplicate your first 2 columns. The matrix is the product of those 3 plus the product of those 3 plus the product of those 3 minus the product of those 3, those plus those 3 plus those 3.
Okay.
So it's very similar to a 2 by 2. In a 2 by 2, we take the product of the positive slope diagonal minus the product of the negative slope diagonal. And in a 3 by 3, it only works if you add these dummy columns.
Okay.
But that's the best way it works, too. I mean, it's not that hard if you put in numbers for everything. Just remember that you're multiplying A times E. So this would be A times E times I plus B times F times G plus C times D times H minus the sum of all the others, G, E, C plus H, F, A plus I, D, B.
Okay. And do we have time to find the inverse of a 3 by 3 by hand?
Probably not. Maybe. No, I don't even think my book covers it, the one I'm looking at. To find the inverse, okay, so the inverse is equal to 1 over the determinant times on a 3 by 3, I don't know. On a 2 by 2, it's, in other words, if your original matrix is A, B, C, D, then it becomes D minus B minus C, A. So that's the way you find the inverse on a 2 by 2. Well, the inverse on a 3 by 3, we know how to find the determinant. We just went through it. Question is what does this matrix look like?
I can YouTube that also.
Huh?
I can YouTube that also.
Yeah, I actually would have to do some searching. In fact, my book only says finding the inverse of a 3 by 3 matrix, and its solution is the calculator solution. Here, I can tell you what it is. No, I can't. They have pictures showing the calculator, but I don't know how to put those in.
It's fine.
YouTube's your best bet there.
Okay.
Okay, sorry I couldn't be a little more helpful on matrices, but
It's fine.
I don't get them very often, so it's hard to stay up to snuff on them.
And I have a friend who needs a math tutor. Could I give her your number?
Absolutely.
All right.
Okay, all right, Griffin. Well, thank you, and good luck on your test, and have a good Christmas, and we'll probably talk to you next semester.
All right. Thanks. You too.
All right, bye-bye.